Hi there. Welcome to this presentation on AutoCAD Civil 3D 2013 New Features and API. I am Partha Sarkar. In Autodesk, I lead the Global DevTech Infrastructure Modeling API group. In this recorded presentation, which we call as DevTV, I will give you an overview of new features in AutoCAD Civil 3D 2013. Cogo Point .NET API is the single most big feature in 2013 release of .NET API. I will introduce it to you in this presentation. Then I will highlight the other enhancements made in 2013 release of Civil 3D .NET API. First, let me go through quickly the new UI features. The 2013 release focuses on a number of key areas that enable you to get more from your survey data, streamline transportation design, and model pressure pipe networks. Let's take a quick look into some of the cool and very useful UI features, starting with the new and enhanced features in survey. In general, there are thousands of items in a survey database that need to be sorted, viewed, and edited. The improved query functionality helps you filter the data in order to find those points, figures, and data properties faster. Additionally, now you can add the search results to your surfaces and utilize dynamic updating when new survey data is collected. There is a significant improvement made in dynamic surface creation process. Before Civil 3D 2013, a lot of manual data sorting was required in order to create a surface containing only the information you need. Now by adding a query to surface, creation is much faster and maintains a dynamic link to the survey database. Surveyors in the field often gather additional attribute information or details about existing infrastructure. These details are useful for creating richer and more intelligent BIM models. Prior to Civil 3D 2013, the additional data was stored but not readily available for presentation or query in a drawing file. With Civil 3D 2013, surveyors can more readily use this attribute information and create more detailed base map and utility plans from their field collected data. There is no need to manually re-enter the information. You can now create more detailed and intelligent designs with additional field information and define queries based on user-defined data. The Subassembly Composer for AutoCAD Civil 3D 2013 software provides a powerful yet easy to use interface to visually modify or create complex subassemblies without the need for programming. The flowchart provides a more intuitive view of the subassembly logic and is easily modified using drag and drop functionality. The graphical preview displays the subassembly geometry and can be used to help simulate how subassembly behave with different target values. Subassembly Composer works directly with PKT files that can be imported into AutoCAD Civil 3D. In previous releases of Civil 3D, there were no explicit tools for the railway designer. While all civil engineers could benefit from the power of Civil 3D objects such as surfaces and corridor models, the geometric design requirements of a railway alignment couldn't be defined. Civil 3D 2013 introduces a new alignment type that includes special features for rail, like chord-based alignment designs and labeling. Railways require special super elevation, that is cant design. Cant is a critical component for railway modeling, and without the ability to define the unique cant requirements, railway designers were unable to take full advantage of Civil 3D's dynamic design model. The new cant wizard for Civil 3D 2013 leads you through the process of applying CAN to your railway alignment. Customizable options allow you to choose a pivot method, design criteria, and other parameters needed to help meet the local specifications. Many types of civil infrastructure projects require pressure pipe networks for both water and sanitary sewer design. Civil 3D 2013 introduces pressure networks, including a large, out-of-the-box catalog of pipes, appurtenances, and fittings in a variety of materials and sizes. This intelligent 3D object helps you to build and document detailed pressure network models. The new Pressure Networks tool in Civil 3D 2013 help streamline the design process. You can create your pressure network in either plan or profile and take advantage of content-driven layout tools that understand how a pressure networks fit together. A visual compass helps you to find just the right bend, while the follow surface tools help you to place the pressure network at an optimal depth. Built-in design checks help you meet the manufacturer and local standards for deflection, diameter, connectivity, and radius of curvature. The new pressure network features include a complete set of tools for labeling and annotation. You can now create alignments that are linked to pressure network parts and dynamically label your pressure network in plan and profile. Additional general improvements to Civil 3D 2013 will help you to improve the overall design productivity and provide features to best define construction staging based on material movement requirements, determine optimal borrow pit location, explore the model in 3D to help uncover potential problems and locations needing additional design consideration. And with that, let's jump into the new API features in Civil 3D 2013. Before I get started with the new features, let me mention about the .NET API namespace simplification introduced in Civil 3D 2013. We have been talking about this since our last year's Developer Days conference. AutoCAD Civil 3D 2013 release introduces a namespace restructuring that simplifies referencing objects. We have fewer namespaces in AutoCAD Civil 3D.NET API assembly compared to the long list of namespaces in 2012 or earlier release. You can see in this slide that in AutoCAD Civil 3D 2013 release, all the feature name or domain levels, that is land, pipe network, roadway, etc., are removed from the namespaces. This change will necessitate your existing projects to be rebuilt by updating the new namespaces. This restructuring of the namespaces will improve the usability by grouping related classes into the same namespace. AutoCAD Civil 3D 2013 .NET API has exposed the Cogo Points and associated functionalities like point group, bulk operations, description keys, and user-defined properties. Cogo Point class is new in Civil 3D 2013 .NET API. It encapsulates a Cogo Point object and associated information. Cogo Point class is available in autodesk.civil.database services namespace. There are a number of very useful member functions that are now exposed for Cogo Point class. And there are many useful properties exposed for a Cogo Point object, which allows us to get and set the properties. I would suggest you to refer the Civil 3D.NET API reference document for exploring the new Cogo Point class. For your information, Civil 3D.NET API reference documentation is available online, and a downloadable version of the same is also available from ADN Developer Center page. Cogo Points and associated functionalities exposed in .NET API enables us creating, updating, or removing Cogo Points. For those who didn't have to deal with Cogo Points earlier, let me give you some basics of Cogo Points. Cogo is short form of coordinate geometry. Cogo Points in Civil 3D are more complex than simple AutoCAD points. which have only coordinate data. A Cogo Point object, in addition to a location, also has properties such as unique ID number, name, raw description, full description, etc. Here is a C# code snippet which demonstrates creation of Cogo Point at a specified location. All the code snippet which I have included in my presentation are already available with more details and expected results in our infrastructure modeling dev blog. I will highly recommend you all to refer the infrastructure modeling dev blog to learn more on API related topics for AutoCAD Civil 3D and other Autodesk infrastructure modeling products. When you select a Cogo point in Civil 3D model space and look into the properties dialog, under data node, there is survey point property and with a value true or false. If the Cogo point is part of survey database, it will be shown as true. Similarly, if the Cogo point is from Vault project points, you would see associated project version in Object Property Manager or OPM window. We can use is survey point and is project point properties to find out if it is a survey point, project point, or a normal Cogo Point object created in the Civil 3D drawing file. Here is the relevant C# code snippet. Description key is a very powerful feature of Cogo Point. Description key and associated functionalities are now exposed in Civil 3D.NET API. Description keys are used to automatically control some of the properties, such as the appearance of a point in the drawing at the time of importing the point or when we create a point in the drawing. AutoCAD Civil 3D provides a nice UI tool, apply description keys, to apply description keys to a single point or a collection of points. C# code snippet in this slide demonstrates how to apply description keys to a selected point using the Apply Description Keys API. This code snippet shows how to create a new point description key sets and add point code using wildcard character. Here is the result of running the code snippet shown in the previous slide. You should see a new point description keys sets added to the collection like the screenshots shown here. Let me repeat. All these code snippets are already posted in relevant topics in ADN Infrastructure Modeling Dev blog. And I recommend you all to refer the Infrastructure Modeling Dev blog to learn more on API related topics on Autodesk Infrastructure Modeling products, including AutoCAD Civil 3D. Let's look into Cogo Point collection object and bulk operation. Performance and scalability are two major factors which influences the design of Cogo Point object in Civil 3D. The Cogo Point database object or DB object is a very simple object containing no data other than its graphical representation for display purposes. All the data for the Cogo Point in a drawing is stored in what we call internally the points node. An abstraction of this node is provided through the API in the form of a Cogo Point collection object, which is exposed by the Cogo Points property of the civil document object. This design allows the Cogo Point collection to expose an interface that makes editing Cogo Points property very efficiently when processing multiple Cogo Point objects. Bulk operations for Cogo Points are very powerful and efficient. When working with Cogo Points, you want to find ways to make edits in bulk better than opening each of the individual objects. The interface exposed through the Cogo Point collection class allows you to write efficient code for editing Cogo Points and provides greater flexibility on how the edits are performed. If you take a closer look into the Cogo Point collection methods, you will see there are several set methods that allow setting properties of the Cogo Point objects contained in the collection. These methods usually have overloads like object ID value. When the method takes an object ID and a value, it is setting the property for a single Cogo Point object. These methods work the same way as if you were to open the object ID for write and set the same property in the Cogo Point object. A second overload will take an enumerable of object ID and a value. For this case, the same value is being set for all the Cogo Point object represented by the specific object IDs. The third overload allows to set the property for each of the specified Cogo Point object and specify individual value for each of them. Cogo Point collection class in Civil 3D 2013 .NET API has overloaded method import points, which we can use to import Cogo Points in a DWG file. In this example code snippet, we can see Cogo Points collections import points methods being used with the point file name and point file format object to import a bunch of points into a DWG file. For your information, we have recently found there is an issue in a .NET API version of import points, which throws an error message while trying to import points in an empty DWG file. We are working on it to fix it now. In the meantime, a simple workaround is just adding a single Cogo Point in the drawing, which you can delete later. If there is any existing Cogo Point object in the Civil 3D drawing file, then you will find import points function call brings all the point from the desired data source without any issue. Let me talk about the point groups now. Point group is an important and powerful feature of Civil 3D. In Civil 3D 2013 release, we have exposed an API that allows you to work with point groups in a drawing. You can create them, modify them, and delete them. The point groups in a drawing are exposed through the point groups property in the Civil document class, which returns a point group collection object. Creating a point group is simple as invoking the add method in the point group collection and passing it the name of the new point group. Civil 3D points can be selected and added to a point group using either a standard point group query object or a custom point group query object. Both of these point group query object inherit from the point group query base class. Standard point group query encapsulates the basic method of creating a query using the GUI. This method uses the tabs on the create point group dialog to match points by raw description, include or exclude specific points or range of points, and to include points from other point groups. To accomplish the same effect using the API, you first create an instance of a standard point group query object, then set the various include and exclude properties to create the query. The custom point group query lets you specify a query string directly and requires a more advanced knowledge of the query operators. This method of query creation allows you to create nested queries that cannot be specified using standard point group query object. Here is a code snippet which demonstrates how to create a point group using standard point group query object. The custom point group query lets you specify a query string directly and requires more advanced knowledge of query operators. This method of query creation allows you to create nested queries that cannot be specified using the standard point group query object. Custom queries are made up of expressions, and expressions have three parts: a property, a comparison operator, and a value. Multiple expressions are separated by logical set operators, that is AND, OR, and NOT. Precedence of expressions and expression sets can be specified using parentheses. User-defined properties allows us to store additional information about a Cogo point. It's easy to create a new UDP classification group. We access the classifications collection through the static method getPointUDP classifications in the UDP classification collection class, which takes an instance of the database. The UDP classification collection exposes an interface to access and manipulate all the classifications in the drawing, as well as creating new ones. Classifications are created by name, and the add method throws an exception if the specified name already exists. You can avoid the exception by calling contains to check for the existence of a classification with the specified name. My colleague Isaac from the Civil 3D engineering team has created a detailed blog post on user-defined properties, that is UDP, in his civilized development blog. I recommend you all to go through the same for a greater understanding of how this new API feature works. Okay, now let me go through the enhancements made to Surface.NET API in this particular release of Civil 3D. .NET version of sample elevations was not included in AutoCAD Civil 3D's 2012 release. However, in 2013 release it's now included. Sample elevations takes an input parameter object ID of type autodesk.autocad.databaseservices.curve, and the curve can be a line, arc, and so on. This slide shows a code snippet on how to use sample elevations. This code sample is already available in our dev blog. Finding the volume of a bounded surface area is new in this release. Surface.getBoundedVolumes calculates the volume of an area defined by several points. The polygon specifies the area where the volumes are calculated. Since the polygon should be a closed one, the start point and the end point must be the same. There must be more than 3 points in the point 3D collection. In the overloaded method, datum elevation is a value of type double. In this case, volumes will be calculated from the specified datum elevation. Here is a code snippet on finding bounded volume. Again, all these samples are already been posted with more details in our infrastructure modeling dev blog. Extract contours is now available in .NET. This function extracts the surface contour information from the terrain surface at a specified elevation interval. Overloaded method takes additional inputs like contour smoothing type that defines how surface contours are smooth, and smooth factor. Smooth factor should be in the range of 0 to 10. A value of 10 generates the smoothest contours. This slide shows a code snippet on extract contours and the results of running these code samples in Civil 3D, which has extracted the contours as a polyline. Extract Border API extracts the surface border information from the terrain surface. Please note the extracted entities can be polyline, polyline 3D, or face. If the surface has no border information, this method returns an empty object ID collection. Here is a code snippet which shows how to use extract surface border. Let me explain you the significance of the surface border display mode settings with respect to the type of object we get when we call the extract border API. If surface border display mode is set to use surface elevation or exaggerated elevation, then the extracted entity using the extract border.NET API is of type polyline 3D. If surface border display mode is set to flatten elevations, then the extracted entity using the extract border.NET API is of type polyline. And in the last case, if surface border display mode is set to use surface elevation and datum options are set to use datum is equal to true, project grid to datum is set to true as well. In that case, the extracted entities will include 3D face. We have a detailed blog post titled Extract Civil 3D Surface Border using .NET API Extract Border in our infrastructure modeling dev blog. I'll suggest you to go through it and try the associated code snippets to understand how it works. Other enhancements in Surface.NET API include Extract Watershed that extracts the surface watershed information from the terrain surface, and Extract Grid that extract the surface grid information from the terrain surface. Pressure pipe network is new in Civil 3D 2013 release. and some of the functionalities related to pressure pipe network are also exposed in .NET API. The new .NET API for pressure pipe is packaged in its own assembly, ACC pressure pipe mgd.dll. And the new features include appurtenances, that is pressure appurtenances class in Civil 3D.NET API. Users can get and set the location of the appurtenances. Graph profile pressure part is exposed through profile view pressure part class. Users can get the source object ID of a pressure part in a profile view. Users can create pressure networks, add curved pipes, and get the current part list object ID of a pressure network. There are some important enhancements in Survey.NET API. The Survey Project Collection is now exposed through Survey Project Collection class. It can be obtained from the Civil Applications Survey Project method. Users can now get as well as set the current working folder for survey projects. The survey project object is exposed in survey project class. Users can now open and close the project, get the project's GUID and name, and get the survey project's queries. Survey queries are exposed through survey query collection class and survey query class. Users can now get the survey query object with the query GUID and access the survey query's properties. Survey query definitions for teen surface are also exposed, including add point, add figure survey query definition. Users can now add data for a teen surface with a survey query and access the properties of a surface operation with the survey query. There are lots of new objects being added to the labels. We tried to cover pretty much whichever was missing from the labels in 2012 or previous releases of Civil 3D's .NET API. If you go through the Civil 3D's API reference document, you would see lots of new labels related classes being added, like parcel area labels, pipe label, catchment label, section view depth labels, node labels and general segments labels, intersection location labels. Stacked profile views are a collection of related profiles that are drawn in separate vertically arranged profile views. We can now create stacked and multiple profile views using .NET API. In AutoCAD Civil 3D 2013 release, stacked and multiple profile views now can be created using profileView.create function. In this code snippet, we can see an example of how we could use profile view to create stacked and multiple profile views using that stacked profile view options. With this, I have come to the end of this Civil 3D 2013 API session. Throughout this presentation, many a times I talked about the infrastructure modeling dev blog. Let me introduce you to our brand new infrastructure modeling dev blog. I have shared the URL here in this slide in case you haven't visited it yet. Infrastructure modeling dev blog is the open resource for software developers working on Civil 3D, Map 3D, Map Server, aka AIMS, Autodesk Infrastructure Map Server, and other Autodesk infrastructure modeling technology. This blog is maintained by our developer technical services, that is the DevTech team. And if you are interested to learn more on other Autodesk products and related API, I'll recommend you to browse through the Autodesk Developer Network open site and get a list of all the APIs related blogs and other open or public resources available to get started on a specific platform or Autodesk technology. We are arranging a live Q&A session on Civil 3D API to facilitate questions and answer based on this presentation. If you have missed the date or time for live Q&A session, don't worry. You can still ask any question on Civil 3D API either through the Civil 3D customization discussion forums or using comments in topics relevant to our blog post in infrastructure modeling dev blog. And all of our 18 partners can always ask or raise a question to the DevTech team using the Partner Center portal. You can also write to me on your Civil Study API question. My email ID is shared here. Thank you very much. I appreciate your time watching this Dev TV.